In this paper, we introduce DP-Recon, Decompositional Neural Scene Reconstruction with Generative Diffusion prior. DP-Recon facilitates the decompositional neural reconstruction with generative diffusion prior, filling in the missing information in unobserved and occluded regions. Remarkably, it reconstructs better object meshes with 10 views than baselines with 100 views. Through SDS optimization, our method supports flexible text-based geometry and appearance editing, as well as scene stylization. Our method also produces decomposed object meshes with detailed UV maps, enabling photorealistic rendering and VFX editing in common 3D software, thereby supporting various downstream applications. Recent decompositional scene reconstruction methods can decompose the latent 3D scene representation into background and foreground objects. However, they lack constraints in unobserved regions or on occluded objects and struggle to reconstruct complete objects and smooth backgrounds. Recent efforts have effectively leveraged diffusion models to provide prior knowledge for reconstruction. However, they fail to decompose objects within a scene, and they often overlook the conflict between generative and reconstruction guidance. Conditioned on the input image, our model first optimizes the SDF for each object in the scene using reconstruction loss. Then, we incorporate a text-guided geometry prior in the form of SDS loss for each object's geometry optimization. After finishing geometry optimization, we export a mesh for each object and also apply SDS loss to optimize object appearance. Although geometry and appearance optimization can fill in missing information in unobserved and occluded regions, they may damage original information in observed regions, leading to conflicts between the guidance from the generative prior and the input images. To alleviate these conflicts, we propose to apply stronger priors in less observed regions and reduce them in more observed regions. As we know, transmittance T in volume rendering represents the probability that the corresponding ray reaches a point without hitting any other particles, and a higher T indicates greater visibility probability in the input views. We use the transmittance in the input views to optimize the visibility grid, and use the visibility map rendered from this grid to dynamically adjust the per-pixel SDS loss during geometry and appearance optimization. In this way, our method can optimize under-constrained regions while maintaining consistency with the input images. Examples from Replica and ScanNet++ demonstrate our model produces higher quality reconstructions compared with the baselines. Our results achieve more accurate reconstruction in less captured areas, more precise object structures, smoother background reconstruction, and fewer floating artifacts. Our appearance prior also provides reasonable additional information in sparsely captured regions, leading to higher quality rendering in these areas compared to the artifacts observed in the baseline results. Our method enables seamless text-based editing for geometry and appearance through SDS optimization. By transforming all objects in the scene into a new, unified style, we can easily generate a new scene with the same layout but different appearance, which could be beneficial for the metaverse. Furthermore, our method produces decomposed object meshes with detailed UV maps that support photorealistic VFX editing. Our model exhibits strong generalization to in-the-wild scenes, such as YouTube videos, achieving high-quality reconstructions with detailed geometry and appearance using only 15 input views. To sum up, in this paper, we present a novel method that integrates generative priors into decompositional scene reconstruction, enhancing geometry and appearance in under-constrained regions. By introducing a visibility-guided adjustment strategy, we resolve conflicts between reconstruction and prior guidance. Furthermore, our approach supports text-based editing and produces detailed, decomposed meshes suitable for photorealistic rendering and VFX editing. Thank you for watching.